This presentation is entitled Soft Methods and Triggers. It is built upon the notion of something called a soft schema. A soft schema is a way of representing something called a graph. Typical graph kinds of transactions consist of either adding or deleting nodes or connections or modifying nodes or connections. What soft methods and triggers enables you to do is attach behavior associated with any of those kinds of transactions.
Soft methods and triggers. Information technology has a number of challenges associated with it. For today's presentation, we're going to look at two. We're going to look at something called fragility. In today's multi-tiered architecture, oftentimes you have the problem where one of the tiers has a change, and that change causes a ripple effect that breaks other layers. The second challenge is one of rigidity. It's the inability to easily modify data schemas on the fly. To address the challenges identified on the previous slide, we're going to look at a technology called TCSQL. In particular, we're going to look at a capability that provides support for something called soft methods and triggers. The object-oriented paradigm can be represented as a graph problem. So here we have a class here called class 1, which has properties A, B, and C, and a hazard relationship between the class definition and its associated properties. We also have another class here called class 1.1 with properties D and E. And we see a relationship here between these two nodes, an is-a relationship, meaning that class 1.1 is a specialization of class 1. Now let's look at a graph here. Let's look at what happens if we want to instantiate class 1.1. Let's look at the equivalent object graph. In this case, it would look like the following. Assuming we want to instantiate class 1.1 and we're going to call that object 1, what happens is the following. We first want to instantiate properties D and E, and then we want to look at this inheritance is-a link here to inherit properties A, B, and C, which is what you see down here. Okay, now let's look at the relational tables needed to support this paradigm here. So we have the notion of a class table here, which represents the nodes of our class graph here. It's basically a name-value pair here, and we have a type column here, and legal type values. This represents basic class types here. We have a class connection table of parent-child nodes here and a connection type here. In this case, it's going to be either has-a or is-a. And then we have a transitive closure table representing the transitive closure of this class graph. And assume for a minute that this transitive closure table is automatically populated and managed whenever nodes or connections are added or deleted in this class graph. Let's look at the tables needed to support our object graph here. We have a table called object, which represents the nodes of our object graph here. Again, it is basically a name-value pair with a class column here representing the kind of class that we're instantiating here, including the class properties. We also have an object connection table here, which represents the connections of our object graph. So it's a parent-child pair, again with connection type. And we have a transitive closure table associated with our object graph. And assume here also that this transitive closure table is maintained automatically whenever nodes or connections are added or deleted in our object graph here. So this whole paradigm here I'm describing here with these 6 relational database tables is something known as a soft schema. With this soft schema model, let's look at an example of instantiating a class instance here. So we have a class graph here, and all the data in this graph can be represented with 2 tables here. So we have a class table representing all of the nodes of this graph. We have a class connection table showing all of the connections here. Now I didn't bother showing all of them. I just showed a few of the rows here. Okay, now let's look at what happens when we want to instantiate this particular node here, a boy. What we're going to do is instantiate this boy. We're going to call this instantiation Andy here. And what is going to happen behind the scenes is TCSQL is going to figure out all of the particular properties that need to be inherited here, and it will populate appropriate object and object connection tables here. And these two tables will represent an object graph that looks like the following here. Notice here that I've introduced a new kind of relationship, a has-not relationship. TCSQL supports the ability to do inheritance override here. Now, if you were to implement this in an object-oriented language such as C# or Java, this is the object graph equivalent of what you would get here. Now, the real power and beauty here is I did this directly in a relational database using standard SQL. Let's take a look at TCSQL's support of soft methods and triggers. So let's look at the following example here. We have this instance graph here of a project broken down into features here, and we have various attributes on some of these entities here. So this is the case where we have a property here, and rather than the human being calculate its value, what we're going to do is have a function that calculates its value. And so we define that in a class model here. So here in our class model we have the notion of a project, which is broken up into one or more features, which is broken down into hardware and software. And we see software has a property called NCSL, hardware has a property called firmware, and both of these are specializations of this more general term called lines here. The project has a property called total lines here. And we have this connection here, a sum of connection here. And this connection has behavior associated with it. And what it says is the following: total lines is derived by lines. And over on the right here, it defines how it's defined here. So we're looking at two kinds of connections: work breakdown structure, which is this yellow here, or object breakdown structure. We see on our instance graph here, this is a graph broken down by work breakdown structure here. And so what it says is we have this sum of field here, a sum of attribute here that takes basically two parameters here. And what it does is the following: whenever one of these guys here, NCSL or firmware, is changed on any of the entities in our WBS graph here, what we want to do is execute this function to update total lines here. So it's a way of automatically populating property values. So why is this valuable? Well, it provides a way of setting attribute values that are based upon either adding other objects to the graph, or deleting objects from a graph, or modifying property values of other properties in the graph.